All right, so the question wants to know which two particles have opposite signs, right? Or something to that effect. Let's see. That was the question. Which phase describes the charge? Oh, I was on a different question. Which phase describes the charge and mass of a neutron? I was thinking of this one. We're going to talk about that next. Charge and mass of a neutron. So we go back to table O. Here's the neutron. Which number, the 1 or the 0, gives us the mass? The 1. Which one's the charge? 0. So the mass is 1, charge is 0. Let's go back to the question. So, no charge, no mass is wrong. No charge and approximate mass of 1 U. You don't know what that U means. That sounds right. Charge of plus 1, that's not right. Charge of plus. So we know 1, 2, and 3 are wrong. Remember, there's two ways to answer a multiple choice question. 100% knowing the right answer, or knowing 100% what the ones that are wrong are wrong. I didn't word that very well. But you can pick the ones that are wrong, and then there's one left over, or you can pick the one that you know is right. Two different ways of doing it. All right, I always tend to make sure I eliminate the wrong ones, so I make sure I pick the right one, because sometimes two questions or two answers will be worded similarly, and if you pick the first one you read, you're like, oh, that's right, without checking the other ones, that's could be a problem. So anyways, the answer is 4, because those don't make sense as far as that does have a mass and it's not plus 1. This 1U, the unit on the masses here is an atomic mass unit, AMU. So 4 AMU, 0 AMU, 0 AMU, 1 AMU, 1 AMU, 0. So atomic mass unit is just the generic term for the mass of elements and of these particles. Now the unit on the mass on the chart, we learned last week and in lab, it's called the molar mass or the gram formula mass. Who remembers the unit on that? So if I want to know the gram formula mass of magnesium, what's the gram formula mass of Mg? What would we do? Oh boy. You're scaring me right now. You learned it last week, we used it in lab.
It's 24.
Thank you. It's 24. When I say gram formula mass, it's just the mass. That's all it is. What's the unit though?
Grams per mole.
Grams per mole. So that's grams per mole, that's the gram formula mass. Another unit instead of grams per mole is AMU, which is atomic mass unit. It's just another unit. That's all it is. That's all you need to know. So the U in this question here, back to number 1, stands for unit. Mass of 1 unit. I think it's stupid. I hate it that they do that because it confuses kids. They're like, what does the U mean? Well, that can't be right. I never learned about U. What's U? I don't understand that. Ignore the U. It's really just you got 1 on top, mass of 1, no charge. So anyways, that's 4. All right, I think I beat that to death, but it's really important that you understand how to use table O, and this is how I teach it. I give you sample problems and we talk about it. I don't give you a whole lot of notes about table O. We just use it, we practice. That's the best way to learn it. 2, what is the number of electrons in a potassium atom? There you go. 19. How do you know? Good. Read the key on the top. Let's tell you. What was that number? Atomic number, right. In a neutral atom, if you see the word atom, it means neutral. What does that mean? It has the same number of protons and electrons. So potassium has a mass of 39, atomic number 19. That is the atomic number. That tells me we have 19 protons and 19 electrons. There's another way to figure this out. What's the electron configuration for potassium? Tyler? Yep.
2881.
2881. Morgan Thomas. What's 2 plus 8?
10.
10. What's 10 plus 8?
18.
18 plus 1? 19. That's the number of electrons. Your electron configuration will always equal the atomic number in an atom, which is the number of electrons and the number of protons. So that's how we answer this question, okay? 19. All right, real quick, let's go back to this one, then we'll go over the worksheet, and then we'll move on here. Oh, you can't read that, it's too small. Number 1. I guess we don't need it that big. Which two particles have opposite charges? Go ahead, answer this yourself. Give you 15 seconds. Think quick. All right, that was 15 seconds. Nicole knows. Yeah, electron and proton. Electrons are negative, protons are positive. How do you know that? Well, you should just know it at this point. I expect you to know that, but you could also look it up on table O. -1 for the electron. Beta means electron. The old reference tables, in parentheses, they used to write electron right here. They took it away. It angers me greatly because they're confusing students. They're making you memorize beta and electron are the same thing. That's not fair. Well, life isn't fair. So, deal with it. Electrons. E stand for electrons. Remember that. -1, proton. Where are we? That's a +1. Yes, it doesn't have a plus sign, but it's positive because it doesn't have a negative. I know that sounds silly to say it out loud that way, but if you don't see a negative sign, then it's a positive number. Unless it's 0, then it's neither. So that's +1, -1. They cancel out. That's why this atom is neutral. +19, -19 adds up to 0. All atoms are neutral. So these practice questions are like warm-up, but you can learn a lot and understand how to use this reference table. Okay? Because I'm not a big fan, like I said, writing a whole bunch of notes about protons are positive, electrons are negative, giving all these pages of notes. Doesn't really help you learn. Okay, so hopefully you're picking it up. All right, so that's it for the warm-ups there. Let's go over this side. I'm going to go through this pretty quick because I want to teach the gold foil experiment today for sure. All right, nuclear symbol. Here we go. 4/2 He, 14/7 N, 9/4 Be. Yeah. 7/3 Li, 20/10 Ne, 19/9 F. 35/17 Cl, 80/35 Br, 40/18 Ar, 12/6 C, 11/5 B, 1/1 H. Questions? Okay, number of electrons. 2, 7, 4, 3, 10, 9, 17. I'm losing track here. 35, 18, 6, 5, 1. Did I make a mistake? Okay. Electron configuration. 2, 2-5, 2-2, 2-1, 2-8, 2-7, 2, 8. Wait, where are we? 2, 8, 8, 7?
No,
287.
All right, I'm thinking of the next one. Sorry. 287. Bromine is 2, 8, 18, 7. Yeah. Argon is 2, 8, 8. Carbon is 2, 4. Boron is 2, 3. Hydrogen is 1. Right? And valence electrons. How do we get that number, Colin?
It's the groups, right?
Well, sort of. Explain it differently. You're right, but explain it differently.
It's
So how many valence electrons does group 1 have?
they have 7. No, 1.
1, right. Group 1 is 1. What about 2?
2.
2. What about 13?
3.
14?
4.
15?
5.
16?
6.
17?
7.
18?
8.
Except? Who doesn't have 8? Group 18.
Helium.
Helium. Good. All right. He's got all that memorized. That's good. But how do we look it up? So he's good with the, he understands to, memorize that. But how do we actually look it up? Aaliyah? The last number right here. Okay? That's the valence electron. So here we go. Helium has 2. Nitrogen has 3. No. 5. Beryllium has 2. Lithium 1. Neon 8. Fluorine 7. Chlorine 7. Bromine 7. Argon 8. Carbon 4. Boron 3. Hydrogen 1. If any of you try and take AP Chem in 2 years, those of you who are sophomores can, juniors obviously you'll be graduated, but you'll see sometimes when I do this, and I'm doing it in my head, but the way the real chemistry is with the electron configurations are very different than we have to teach in a region, so I get all confused sometimes. That's why sometimes I make mistakes, because I'm trying to think of it different ways. I would teach you the real way, but it's not on the regions, and I don't need you getting confused. So, if you ever want to learn the real way to learn electron configuration, you stay after school. We'll have a chemistry party about it. All right. Probably not going to happen. Let's go over this side. If you're curious, I take 1 day in lab to teach it. So I do teach the real electron configuration in lab in Regents Chem. It'll be probably the week, maybe not next week, the week after. Yes, sir.
Your iPad stopped recording.
I'd like to smash it then. Oh no, it didn't. It's just assigning. It says sign into iTunes. No. Yeah,
Country music.
we're good. Okay. Thanks, Watson, for looking out though. All right, here we go. 1. Same family. Now, family means group. I mentioned that a long time ago, so hopefully you realize that. Same family as lead has fewer protons than Na. Colin.
Carbon.
Carbon. Yes, because carbon has 6. It's in group 14, and it's less than number 11. Good. More protons than chlorine, but less than potassium. Matt Payne.
Argon.
Argon. 3. Atomic numbers below sodium. It's a metal in the same family as sodium.
Lithium.
Lithium. It has more valence electrons than S, fewer protons than Ar. Watson. Chlorine. Yep. 5. Its atomic number is 1 above Au. That's easy. Hg. Mercury. Half as many protons as zinc. Who's number 15? Colin. Phosphorus. If this element had one more proton, electron, and neutron, it would be zinc. Just go with one more proton on that one. Copper, right, because copper is 29. We're going to learn today how to figure out the number of neutrons. 8. Its group 1 has a higher atomic number than Ar, but lower than Br. That's got to be K, right?
Mm-hmm.
Yeah, potassium. Most protons in group 14. Olivia. Lead. Yes, 82. It's in the same group as magnesium and has fewer electrons than any element in that group. Nicole?
Beryllium.
Yeah, beryllium only has 4. More electrons than aluminum, fewer protons than phosphorus. Anybody? Colin?
Silicon.
Silicon, let's see. I think you're right. Yes. Fewer neutrons. All right, so here's how we find the number of neutrons, okay? And we will take some notes on this, but let's say, what is this question asking? Fewer neutrons than carbon, and it's in group 2. So carbon, what's the nuclear symbol for carbon? What's the top number? 12. What's the bottom number? 6. Okay, look up here. Here's how we do it. We always write protons, neutrons, electrons. That's kind of the order I do it in. This number tells me the protons, that number tells me the electrons. That's easy. If it's an atom, which this is an atom, and the reason I know it's an atom is if it has a charge, like a -1 or a +1, it'd be right up here in the top right corner. And we're going to talk about that down the road here, but those are called ions or charges, but this is an atom because there's no charge. It's neutral. So 6 positives, 6 negatives. Positive, negative, neutral. How do we get the neutrons?
Don't you subtract the atomic mass by the atomic?
Yep. This is set up like a subtraction problem. 12 minus 6, so the answer is 6 neutrons. That's how we do it for all of the elements. You set up your nuclear symbol. It's why it's so important to set this up correctly. 12 minus 6, 6 neutrons. It's not uncommon for a lot of elements to have the same number for all 3. That's actually really stable. That's a good thing. Anyways, now we know how to do it. Who has less than 6 neutrons than carbon, but it's in group 2? Right? Fewer neutrons than carbon and is in group 2. What is it? Beryllium, because if you set up the nuclear symbol for beryllium, Be is 9 over 4. 9 minus 4, you have 5 neutrons. 5 neutrons, that's less than 6. All right, more neutrons than Na, fewer electrons than Al. So Na, let's see, Na is 23 over 11. How many neutrons does it have? You just subtract those numbers. How many neutrons? 12. So that's 12 neutrons. So this question here says more neutrons than Na, but less than 13 electrons. Al has 13 electrons. So has to be magnesium. Has to be. Mg is 24 over 12. That's 12 neutrons. Wait. That's not right. Yeah, that's not right. Is there no answer for this question? Right? More neutrons than Na. Right.
You said 13.
Well, Al has 13 electrons, so it has to have less than 13 electrons.
Or they could be using sodium as 22 for mass. Maybe they didn't round it.
Yeah, I mean, there is a way to answer this, but this is a bad question. So skip this one. Skip that one. 14. It has more than 50, but less than 80 electrons and is in group 17. Iodine. Iodine is the answer. It has 53 electrons. Okay. Running out of time. What else is new? I want to talk about the short answer on that test. We have to do that. So go to that test. Let me turn this off for a little bit here. All right. So everybody go to number 34 and 35 and 36. That's the last three questions on the first part that you took on Thursday. All right, so if we don't have time to learn the gold foil experiment, that's life's going to be okay. 34, it's giving you a chart. And the chart, or table, whatever you want to call it, has 5 elements. It has carbon, silicon, germanium, tin, and lead. If you got 34 wrong, I mean, I don't know. There's certain things I think that are unacceptable. That's unacceptable. You should not get 13 wrong. No one should get 13 wrong. It's a very easy question. Why is it easy? Look over here. What do you call all these elements? Look over here on the right. What do you call all these elements except for aluminum touching the staircase here? Metalloids. So when this thing is asking for one metal, one metalloid, and one non-metal, all you need to remember, very simple skill, is that the metals, look over here, metals are over here, non-metals are over here. Metalloids on the stair. That's all you need to remember. That's it. So again, when I say things like that's unacceptable, if you get it wrong, it doesn't mean I'm like angry at you. It just means don't do that again. Okay, learn from this. Remember where the metals, non-metals, metalloids are, because questions like 35, if you get wrong, I can kind of see it. 34, you got to get those points, right? Whether you're going for 100 on this test or you're trying to get an 80 on the regions, whatever your goal is, you know, hopefully it's you're pretty high grade. You need to get 34 right. Whatever your goal is, that's the one you got to get. So I think you understand my point. So if you look at that chart, they give you only one non-metal. Which one is it? Out of those 5 elements, there's only one non-metal. Carbon. So that one should have been easy. See, if you look over here again, staircase here to the right, so all the way over here, all of these are non-metals. Carbon is to the right of the staircase. That's a non-metal. And then over here are the metals. So tin and lead are the only 2 metals they give you. Tin and lead, Sn. So those are your 2 options for metal. You could have one or the other. Doesn't matter. It's the metalloids. I think some of you got confused. Si and Ge. Si is not a non-metal. Ge is not a metal. They are metalloids because their squares are touching the staircase. Like the whole side of the square is touching the staircase. So those are your 2 options for metalloid. So again, look over here. Let me go through these one more time. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These, all right, those 7, right? 1, 2, 3, 4, 5, 6, 8. Those 8 are metalloids, okay, not aluminum. So again, that's more of a memorization, but you shouldn't be getting that wrong. All right, 35. I was a little alarmed with this one. The density equation is mass over volume. Oh, and good thing I didn't have to grade the units, because I don't think anybody, not one of you, had the units correct on your answer. Everybody, let's see, calculate the volume. Actually, that's not true. Maybe it was the other class, but there was maybe it was the other class, but there was a whole bunch of tests I graded that the unit was wrong. So maybe it wasn't in here, so I apologize. But anyways, units weren't that important because it didn't specifically say label units. You should always label units, but it didn't specifically say it. What's that? Well, it does, and I'm going to explain that. So, calculate the volume. Now, it has a mass of 95.04 grams. So, M is 95.04 grams. That goes on top. X goes here. Calculate the volume. Where's the density come from? Come on, don't zone out on me. You're trying to learn if you made a mistake here. Where's the density come from? From the table. Did anyone go to table S and look it up? Matt Payne, did you look on table S?
I think I did.
Yeah, I think you did. So you got it right?
Yeah.
Yeah. So you could have gone to table S on your periodic table and look up the density of, what are we dealing with? Tin. But they gave it to you. 7.31.
Yeah.
Look up here. Because you wrote 7.2.
Yeah, 7.287.
Yeah, that's fine. That's good. That's great. You guys did a good job. But they gave it to you, so you didn't have to do that. 7.31 goes here. 7.31 grams per centimeter cubed. So centimeters cubed is our answer's unit. Okay, that's a volume, mass divided by volume, mass divided by volume. So x is going to be centimeters cubed. How do we solve for x? So I was surprised at how many tests I was grading that the students would set this up right. I sound really formal. You guys would set this up right and then get the wrong answer. I don't know what the deal is with that, but you just cross multiply, so it's 95.04 divided by 7.31, right? Because 7.31 times x equals 95. So anyways, the answer is 13.0 centimeters cubed. It didn't even tell you to round or significant figures, but it would be 3 sig figs, 1, 2, 3. So 13.0 was the answer. If they asked for sig figs, it would be 3 because 3 is the lowest number. All right, so that was that. All right, 36. Oh, 36, 36, 36. What do we call the Mickey Mouse? What do we call the water molecule? Mickey Mouse. What's Mickey Mouse's head look like? This with this and this. All right, there's Mickey Mouse. Is that oxygen or water? I mean, hydrogen. I'm all over the place. That's oxygen. H2, so 2 H's and an O. So this is H, and that's O. If you look at the key, hydrogen is shaded in, and oxygen's open, or white, or not shaded, whatever you want to call it. So what you needed to do was draw 5 of them. Didn't it say 5?
It said at least 5.
At least 5, and it has to be a gas, right? So why does it have to be a gas? Because it says the product is drawn in the box. 1, 2, 3, 4, 5. Something like that. Okay, I'm getting kind of messy to hurry up here, but if you read it says, draw a particle diagram to represent at least 5 molecules of the product. The product is H2O gas. I graded some tests where they put the gas and liquid both in the box. I had to take a point off. They didn't want the liquid, they wanted just the gas. And then some students flipped the colors around. They gave me 1 hydrogen and 2 oxygens. So that would be HO2. Don't do that. Okay. 37. Go to that other sheet now. So I guess I'm just going to finish up class going over this. You do not have any homework. 37. All right. If you look at the chart or the table, methane, ethane, propane, butane, pentane, they all boil at pretty low temperatures, except pentane is a positive number, right? 36 degrees above 0. All the other ones are negative. So 37 is asking which of those alkanes. You don't have to know what an alkane is. You can read the chart. It says formulas and boiling points of selected alkanes. So you may not know what the word alkane means. Don't let that scare you. Just go to the chart, look at the names. Now, 298, what is that in Celsius? That's what you had to really do here. You had to convert that to Celsius. It's 25 degrees. 298 minus 273 is 25 degrees Celsius. At 25, only one of these liquids, one of these alkanes will be a liquid because it hasn't boiled yet. Pentane. Pentane boils at 36. So at 25, pentane is still going to be in a liquid state. The boiling point is 36. It hasn't reached the boiling point yet. It's still a liquid. Methane, ethane, propane, and butane have already boiled. They boil below 0. They're already gases. 39. What's the boiling point in Kelvin? This is a ridiculously easy question as well. You cannot get this wrong. Okay? Use a calculator. All you do is add 273 to Celsius, right? So what is it? Propane? Propane, negative 42 plus 273 is what? 231, right? 231. Again, you cannot get that wrong. I don't care what your goal is. on what your grade is going to be on this region, so you cannot get that one wrong. 39. If you look at the volume of mg, it says a piece of mg has a volume of 0.0640. They want to know how many sig figs. And I'm getting redundant here, but you cannot get this wrong. You cannot get this wrong because it's an easy question. Okay? Think about some of the hard stuff we've learned. Just counting sig figs is really easy. Hold on real quick. Present, decimal point present. Go from the Pacific. You just can't start with zeros. 1, 2, 3. 1, 2, 3. Don't lose that. I want to finish going over that Monday. I've only got a couple left here. No homework. And enjoy Thanksgiving and the weekend.